Hello everyone, today I will be presenting a demonstration of how to execute a RISC-V assembly program using RAPS, a visual processor simulator. First, let's look at the setup. We need to configure our hardware. I will click on Selector Processor in the menu. For this demonstration, I'm choosing the 5-stage processor without forwarding or hazard detection. This setting is very important because it allows us to observe the raw behavior of the pipeline structure without any complex optimization logic hiding the detail. Now let's switch to the processor view. And we will follow the very first instruction of our code to see exactly what happened inside the hardware. The instruction flows through 5 specific stages. Stage 1 is instruction fetch. Here the processor fetch the instruction from the instruction memory. And next, stage 2 is instruction decode. In this stage, the control unit decode the instruction to understand what to do. It also read the necessary value from the register file. And next, step 3 is execute. This is where the actual calculation happen. Since our instruction is an addition, you can see the ALU performing the math operation. And next, step 4 is memory access. Uh, in this specific instruction, we are only doing calculation, not saving data to RAM. So the data simply pass through this stage unchanged. Save file is right back. Finally, the calculated result travels all the way back along the wire to the writing into the destination register. At this point, I want to direct your attention to the right side of the screen. Here you see the GPR, and this plan shows the real-time state of our memory. Now as the write back stage is complete, you will see the value of X11 update instantly to the final result. This confirms that our calculation was successful and the data has been safely stored. The following two instructions in our code follow this exact same path, and however, they don't wait for the first one to finish. And here we see a chart that looks like a staircase. This visualizes a key concept called instruction level parallelism. And finally, looking at the diagram, we can see that the total execution for this instruction took 7 clock cycles to complete. And thank you for your listening.